Okay. So today we're doing lesson 4.1. This is actually lesson 4.1, Introduction to Rational Functions. So consider the function f of x equals 3x plus 1 all over x minus 2. This is called a rational function, and we already talked about this. Why is it rational? Because we have a variable in the denominator. Okay? So all rational functions can be written in this form. F of x equals a of x over b of x, where a and b are also functions. So the first thing that we're going to do is investigate this function. So when you look at the definition, this is just one function divided by another function. How do I know this is a function? Because if I graph it, it passes a vertical line test, right? Okay. So name the two functions that compose f of x. Well, a of x is the function 3x plus 1. Again, if I graph that, I begin at 1. I have a slope of 3. That passes a vertical line test. So I know that 3x plus 1 is a function. B of x is the function x minus 2. If I graph that, I begin at negative 2 and I have a slope of 1. That also is a function. It would pass the vertical line test. So it says complete the table below using the three functions listed, and you can do this very quickly using your calculator. So everybody grab their calculator. We're going to put all three functions in our calculator. So go to y equals. Y equals. Pick up your stinking calculator. Don't make me ask you. Go to y equals. I would probably hit clear first. The first function that you're putting in is the ax function, which is just 3x plus 1. Go down to y2. That's where you're going to put the b function, which is x minus 2. For y3, you need to use parentheses. Parenthesis 3x plus 1, close your parenthesis, divided by parenthesis x minus 2. If you don't use parentheses, it doesn't factor right. It doesn't think properly. Now I want to look at my table of values. I forgot how to do that. Who can help me? Second graph. The fraction. Parenthesis 3x plus 1, close your parenthesis, divided by parenthesis x minus 2, close your parenthesis.
Oh, you can put fractions in there.
Yeah, I know you can. It's just easier to use parentheses, I promise. Okay, so I have to start with negative 5 on my calculator. When x is negative 5, what is a of x? That's my first one. I think it's negative 14, right? Yeah. When I let x equal negative 5, what is b of x? Negative 7. What is negative 14 divided by negative 7? 2. Let's go to the y3. Did you get a 2? In your table, y3? If you arrow over, do you get a 2? Yes, you do. That makes sense. What about negative 4? So when I let x equal negative 4, y sub 1 is, y sub 1 or a of x is negative 11. When I let x equal negative 4, b of x is negative 6. Let's see, negative 11 divided by negative 6 is a positive 11 over 6. Right? Yeah, it's a of x divided by b of x. This is about 1.8. Okay, it's about 1.8. What about when you let x equal negative 3? A of x is negative 8, and b of x is negative 5. Negative 8 divided by negative 5, well, that's 8/5, which is about 1. It's not about anything. It's exactly, it's exactly 1.6, right? Okay. Well, what about when you let x equal negative 2? When x is negative 2, a of x is negative 5, and b of x is negative 4. Negative 5 divided by negative 4, well, that's a positive 5/4, and that actually equals 1.25. What about when you let x equal negative 1? Well, a of x is negative 2, b of x is negative 3, Negative 2 divided by negative 3 is a positive 2/3, which is about 0.67. We know that it's 0.6 repeating, but we're just going to round it to 0.67. What about when x is 0? When x is 0, a of x is 1, and b of x is negative 2. So 1 divided by negative 2 is negative 1/2, which is negative 0.5. You guys get what I'm doing? Okay, what about when x is 1? Start shouting them out. When x is 1, you get 4 and? So negative 4, or sorry, 4 divided by negative 1 is just negative 4. Yeah. What about when I let x equal 2? What are my two outputs? 7 and 0. What is 7 divided by 0? What? It's undefined. Scroll over to your output, your Y3. What does it say in your calculator? In your table, what does it say under Y3? It says error, because you cannot divide by 0. It's a divide by 0 error. Cannot divide by 0. That's why it says that. What about when you let x equal 3? Well, 10 and 1. 10 divided by 1 is? Okay. What about when you let x equal 4? 13 and 2. 13 divided by 2 is? 7.5. And when you let x equal 5, and 16 divided by 3 is the same thing as? Yeah. I'm just going to write it as 5 1/3. Okay. So now we're going to plot these points. We're going to plot these points. So I need my x-axis to go from negative 5 all the way to positive 5. So I'm just going to try to divide this up neatly. Negative 1, negative 2, negative 3, negative 4, positive 1, 2, 3, and 4. So I'm just, each grid line or each mark represents 1. The smallest number that I go down to looks like negative 4. The largest number that I go to looks like 10. Do you guys see that? The smallest value in my range on this graph is, the smallest value is right here, negative 4, and the largest value is right here, positive 10. So negative 1, let's see, I'm going to do this. How do I want to count this? So I'm going to make this negative 2, negative 4, negative 6, negative 8, negative 10. That's kind of how I'm going to count. Positive 2, 4, 6, 8, 10. Okay. So when x is negative 5, my output is positive 2. That's right here, because remember I'm counting by 2's. When x is negative 4, my output is 1.8. So it's decreasing a little bit. When x is negative 3, my output is 1.6. When x is negative 2, my output is 1.25. When x is negative 1, my output is 0.65. And when x is 0, my output is negative 1/2. Okay, well, what about when x is 1? My output is negative 4. What about when x is 2? It's undefined.
I'm sorry for interrupting. When they click on to do the homework page, the 12 and 13 access is denied.
That's fine. They have the packet. They were given the packet yesterday. Okay. And if they don't have it, listen to this.
I've got some.
And I printed extras as well, just because I wasn't sure what.
Clicking on it, and
It's because I copied it over. This is what their homework is. Front and back.
are these your copies?
Yeah, isn't that 3.5? Yes, ma'am. Okay. Yep. So I printed extra, not knowing that they were given a packet yesterday. Thank you. Okay. So why did I draw a dashed line there? Well, because it's undefined. That means that I can never let x equal 2. So listen up. So this side of my graph kind of looks like this. Right? So what does the other side of my graph look like? Well, when I let x equal 3, when x is 3, I go all the way up to 10. When x is 4, my output is 7.5. So 10, 8, 7.5 is about right here. And when x is 5, my output is 5 1/3. Okay, so this is going to look something like this. Okay, so it says, what about this unique value f of 2? Well, what is the unique value? What happened? You get an error. Why do you get an error? Yeah, because you get 7/0 and you cannot divide by 0. So what is the cause of this result? It's a divide by 0 error. And most of the time, like if you were to just not, like if you were not under tables or y equals, if you just did 8 divided by 2, I'm sorry, not 8 divided by 2. If you did 8 divided by 0 in your calculator, you should get error, and it tells you what the error is, divide by 0. You don't have enough space in that little table for it to write error, divide by 0. Does that make sense? Okay. All right. How does this result affect the graph of the function? Well, first of all, it creates a vertical asymptote. At x equals 2. Okay. It means that the graph gets close to that, but it can never touch it, right? So let's talk about the end behavior. What's happening to the end behavior? Like as x gets really small, approaches negative infinity, what's happening to this? Well, let's see what happens when I put -6 up here. Go to your table. What happens when x is -6? What's your output? The last one. When I have -6 there, what is a of x? Y sub 1. Okay. What's b of x? What is 17 divided by 8? Okay. Let's try -10. What happens when I use -10? What's my output? Just give me the last number, the last column.
2.4167.
What about -20?
2.68.
It's getting closer to what number?
0.
What's happening? Look at this. It's getting closer to not 2 because it's already at 2. We got a 2.125, then a 2.3, and then a 2.6, and then what about when x is -100? Find x is -100 in your table. Tell me what you get for your final answer.
Just a second.
-100. Just arrow up.
Can you just type in?
It is 2.9313.
So it's never going to reach the number 3. So as x gets really small, y approaches 3. So y approaches 3. But it doesn't touch 3. So that means that you also have a horizontal asymptote going this way at y equals 3. Okay. As x gets really, really, really big, as x gets really, really, really big, what happens to it? What do you think y approaches? So go to like, you think it approaches 2? Look at that line that I drew across that horizontal line. Go to when x is positive 100 on your calculator. Go to really big numbers.
You said positive 100?
Sure.
3.071.
Okay. So do you think it's ever going to touch 3? It's always going to be above 3. Okay. So as x gets really, really, really big, y approaches 3. But again, it never touches it. So how is the end behavior function different from the end behavior of a polynomial function? Well, the end behavior approaches the horizontal asymptote. We usually abbreviate that HA. It approaches the horizontal asymptote instead of approaching a positive or a negative infinity. Because it used to be like when we talked about a polynomial function, we said end behavior, up, or down, up, down, right? Depending on the degree. As x gets bigger, y either approaches positive infinity or negative infinity, and vice versa. But this isn't doing that. This is approaching the horizontal asymptote. Okay? This is approaching a horizontal asymptote. So we're going to do some investigating on rational functions, and we're going to open up Desmos. So for each of the following functions, determine the x and the y intercepts, discontinuous, which would be holes, vertical and horizontal asymptotes, domain, range, and end behavior. I am going to split my screen. We're going to do like 3 of these together, and then we'll pause, and we'll finish the rest of it up tomorrow. So I'm going to try and split my screen so I can go to Desmos graphing. But I would encourage you guys to open up your computer and also go to Desmos graphing. Oh, you're so awesome. Thank you, dear. So I keep track of that other class that I'm helping out with. All right. So our first question is f of x equals 1 over x. So that's the same thing as saying y equals 1 over x. Let's talk about things that we notice. It wants us to determine the x and the y intercepts. We're looking at the holes, the vertical asymptote, and the range and the domain. So here's how we're going to write this. We're looking for x and y intercepts. So where does this cross the x-axis? Does it? No, it doesn't. There is none. What about the y-intercept? Where does it cross the y-axis? It doesn't, so there is none. Okay, let's talk about holes. Holes. Holes are things that put a 0 in the denominator. If we were to look at our table of values, you see that it's undefined when x equals 0. Okay, well, you're gonna have to just watch. So it's undefined when x equals 0, but it never crosses the y-axis, right? So there is no hole. What about a horizontal asymptote? Horizontal, right, is a horizontal line. So is there some horizontal line that you can see across that graph that the left side and the right side never cross? Sure there is. Look at this side of your function and look at this side. Where is the horizontal line that they never cross?
0.
X equals 0. Okay, it's x equals 0. Or sorry, y equals 0. Horizontal line, y equals 0. What is the vertical asymptote? What's the vertical line that they never cross?
X equals 0.
X equals 0. Good job. So your horizontal asymptote is the horizontal line, y equals 0. And the vertical asymptote is the vertical line, x equals 0. So let's talk about my range. I'm gonna do range first because it's the easiest. What numbers am I able to put in here? Range is your outputs, right? So what are your outputs? All real numbers, but y never equals 0. Just y can't equal 0, right? Because that's a no-no. If like it doesn't cross that line, it doesn't cross the line y equals 0. Your domain, we have to think about what is it approaching, and remember that your domain approaches the horizontal asymptote. So as x approaches negative infinity, as x gets really small, what does y approach? As x gets really, really small, remember we said that rational functions are different because the domain talks about it approaches the horizontal asymptote, which is this right here. So as x gets really, really small, y almost equals what? Y almost equals 0. So y approaches 0. And that's what this arrow means. When we draw this arrow, it says y approaches 0. It doesn't equal 0, but it approaches 0. Well, what about as x approaches positive infinity, as x gets really, really big? So as x gets really, really big, what does it do? As x gets really, really big, as I look along my x-axis, as x gets really, really big,
It's closer to 0.
y approaches 0. Yeah. Okay. So that's number 1A. Now let's do 1B. So I'm going to change this. I'm going to get rid of this, and I'm going to change my equation to 2 over x minus 6. Okay, so let's do the same thing. Where do I cross the x-axis? And where do I cross the y-axis? Does it cross the x-axis ever? You cross the x-axis when y equals what? When y equals 0. Is it crossing the x-axis? What do you guys see? Okay. So what if you were to put a table up here? Does it cross the x-axis? Does it cross the y-axis? Well, I think it definitely crosses the y-axis. It looks like it crosses it right here. What is that number? Which is -1/3, right? So the y-intercept is negative 1/3. That kind of looks like those two numbers. What does 2 over negative 6 reduce to? Negative 1/3. Okay. Where does it cross the y-axis? Or the x-axis? Does it ever? It doesn't. It has a what? Has a vertical asymptote there, yeah. So there's no x-intercept. What about holes? Well, remember, holes happen when you get a 0 in your denominator. So what value would put a 0 in your denominator? 6. So let's go to when x is 6. And you see that when x is 6, well, that's not going to happen because that's our asymptote, right? So we don't have any holes. Holes happen when you can cancel stuff out from top and bottom. What about a horizontal asymptote? Well, that's the vertical asymptote. Sure, we'll write it down. Vertical asymptote is x equals 6. Horizontal, what line does it not cross horizontally? Y equals 0. Okay. What about our range? Well, we know our range is all real numbers except what? What can't y equal? Yeah, y can't equal our horizontal asymptote, which is what? Y cannot equal 0. But what about our domain? What about our domain? Well, as x gets really, really small, so as x approaches negative infinity, what happens to y? What's your horizontal asymptote? Y approaches 0. As x approaches positive infinity, y also approaches 0, just from the other direction. Okay. I'm going to freeze that and I'm going to stop for a second. We're going to go to our journal.